are doing the UPSC PYQ analysis of the prelims paper. So we are doing the topic-wise PYQ analysis. Today's topic will be the continuation of the physical geography, and it is the part 3 of this particular topic. So let us start with today's class. The first question would be, consider the following statement. Statement 1, most magmas are a combination of liquid, solid and gas. Statement 2, water vapor and carbon dioxide are the principal gases dissolved in a magma. Statement 3, basaltic magma is hotter than the silicic magma. Statement 4, the magma solidified between sedimentary rocks is in a horizontal position is called as dike. So first of all, they are talking about the magma here. Okay, you all know what is a magma. The magma is a liquefied particles or liquefied rocks which are there inside the interior of the earth. Let us say this is the surface of the earth. So in the mantle, in the upper mantle, we have this particular layer. What is this layer? That is the asthenosphere. So this particular asthenosphere, this layer contains the major magma chambers in the earth. Okay, so this particular magma which are there in the interior of the earth, sometimes what happens, they used to come out of the earth. So when there is some sort of a crack in the crust, or when there is some sort of a volcanic activity, then through volcanic eruption, these magma, they try to come out of the surface of the earth. So what is the difference between magma and a lava? Just try to understand or tell me what is the basic difference between magma and lava. If you see, most of the time we used to use these two terms. These two terms are considered same, like they both are the same terms. But there is a difference between the magma and the lava. So what is that basic difference? When you see here in the asthenosphere, the magma chamber, there is magma. So whenever there is magma inside the earth's interior, we call them as magma. But once this particular magma tries to come out of the earth's surface, either through the volcanic eruption or through any crack in the crust, whenever this particular magma is trying to come out of the surface of the earth, we call this as lava. So this particular magma is nothing but when it is inside the earth, we call them as magma. When they came out of the earth, they are on the surface of the earth, we call them as lava. This is the basic difference between the magma and lava. So this particular question is talking about the magma. So first statement says that most magmas are the combination of liquid, solid and gases. So if you see, the magma is kind of a liquid thing, right? It contains the magnified, or it contains the liquid portion of some rocks or some minerals. Okay, so anyway, it is a liquid. Yes, it also contains some sort of solid particles. Okay, so it also contains solid, and it also contains some of the gaseous particles like carbon dioxide, sulfur dioxide, nitrogen dioxide. So these are some of the constituents of the magma. So in the first statement, they are saying that most magmas are a combination of liquid, solid and gas. Yes, this particular statement is correct because most of the magmas, they are the combination of solid, liquid and gaseous particles. Then statement 2, water vapor and carbon dioxide are the principal gases dissolved in the magma. Yes, as I told you, the major constituents, if you see, they are water vapor and the carbon dioxide. And apart from that, there are other gaseous compounds also, but these are some of the major gaseous compounds, that is the water vapor and the carbon dioxide. So yes, this particular statement is also correct. Then statement 3, basaltic magma is hotter than the silicic magma. So basically there are two types of magma. One is the basic magma, the other one is the acidic magma. Okay, so these two magma are also called as the basaltic magma or the silicic magma. only because this magma contains more of a basaltic or basalt, basalt rocks. But in this type of magma, the silicic magma, they contain more silica. Okay, that is the difference. So what they are saying in this statement, basaltic magma is hotter than the silicic magma. Is it true? Yes, basaltic magma is comparatively hotter than the silicic magma. The fourth statement, the magma solidified between the sedimentary rocks in the horizontal position is known as dike. So again, if you see, whenever this magma from the magma chamber, where is this magma chamber located? Most of the cases, the magma chamber is located in this particular layer known as the asthenosphere. Let's say this is the surface of the earth and this is the asthenosphere. So this particular magma try to come out of this particular surface of earth, and this most of the magma chambers, they are located in this particular layer, that is the asthenosphere. And sometimes while trying to come out of the surface, they will be trying to come out like this. There will be some crack or some space inside the crust. So what happens is this magma, they go and fill that particular crack or that particular small spaces in the crust. Then what happens after some time, these magma gets solidified. So this particular magma which is filling the cracks, it will get solidified and they sometimes form some of the features. What are these features? These features are called as the intrusive volcanic features. Especially if you see the volcanic features, there are both types. One is intrusive, the other one is extrusive. What is intrusive? Intrusive is it is inside the surface of the earth. It is in the interior of the earth. So that's why it's called as an intrusive volcanic feature. And the extrusive volcanic feature is nothing but it is above the surface of the earth. Simple. So here we are talking about the intrusive volcanic features. They are found below the surface of the earth. So there are different type of features we can see. One of such features is dike. So what is this dike? Dike is something which is near vertical position. It is not something of horizontal position. When something is of horizontal position, we call them as sill or sheet. When there is some intrusive feature which is in the vertical position, we call them as dikes. So this particular statement is wrong because they are saying the horizontal position is dike. No, this is wrong. The vertical position, the vertical intrusive feature is called as dike, not the horizontal position. So we can eliminate this option. So what would be the correct answer? 1, 2 and 3. Option A is the correct answer. So if you see here, as I already told you, basically this magma can be categorized into two major categories. One is the basic magma and the other one is the acidic magma. Obviously the basic magma, they are going to be of dark color because they have basalt. Okay, that's why this particular basic magma is also called as what? The basaltic magma. Okay. And this particular basic magma, it is rich in iron and magnesium. Okay, then, but it is poor in silica. As we saw, apart from the basic magma, there is another one, that is the acidic magma. The acidic magma is also called as silicic magma. Why? Because it is rich in silica. And this basic magma, it is poor in silica. Silica is very less in this particular magma. And they travel far and generate broad shield volcanoes. So they travel far and generate broad shield volcanoes. So this particular basic magma, they are usually seen in the shield volcanoes. And these shield volcanoes, this lava is going to be traveling far distance. Okay, then we have the acidic magma. So what is this acidic magma? This is somewhat in light in color compared to the basic magma and of low density and have a high percentage of silica. As we saw in basic magma, it is poor in silica, but in acidic magma, it is rich in silica. Then therefore it makes a familiar cone-shaped volcano. So usually when you see the cone-shaped volcanoes, these are somewhat higher height. If you compare with the shield volcanoes, this type of volcanoes are somewhat high. And then this particular volcano, this lava is mostly made up of this acidic type of magma. So if you see here, these are some of the intrusive volcanic features. As we already saw, this magma is trying to come out from the interior of the earth and it is going to come out from the volcanic eruption. While trying to come out, what happens is there are some of the cracks or some of the gaps in the crust. What happens is this magma go and fill this particular cracks or gaps in the crust and they form some of the features, physical features, and we call them as intrusive volcanic features. So what are these intrusive volcanic features? One is batholith. What is this batholith? This is a bulk of magma which got solidified, and we already saw this magma while try to come out from the astrosphere, it gets solidified in its way, and this large bulk of magma is called as batholith. And we have something called as stalk. This is comparatively smaller than the batholith. And we have dike. What is dike? Dike is somewhat vertical. If you see here, it is a near vertical feature. So this particular feature is called as dike. We can also say dike. The spelling can vary. Then the other feature is laccolith. What is this laccolith? These are some of the features which are in dome shape. And sill, we saw in that particular question, it was some of a horizontal feature, near horizontal feature, and we call them as sill. We can also call them as sheet. When this particular feature, horizontal feature, is somewhat thicker, we call them as sill. And when it is somewhat thinner, we call them as sheet. So these are some of the intrusive features. Apart from that, we have another feature, that is lapolith. Apart from laccolith, this is lapolith. It is saucer shaped. It is saucer shaped feature. Okay. Then we have pacholith, that is of this shape, disc shape. Okay. So these are some of the intrusive features of the volcano. Then let us go to the next question. Consider the following statements regarding the earthquake. Statement 1. The intensity of the earthquake is measured on Mercalli scale. Statement 2. The magnitude of an earthquake is measured of energy released. Statement 3. Earthquake magnitudes are based on direct measurements of the amplitude of a seismic wave. Then statement 4. In the Richter scale, each whole number demonstrates a 100-fold increase in the amount of energy. So basically they are talking about the two types of scales which we have to record a earthquake. What are these two scales? One is the Mercalli scale and another one is the Richter scale. So this particular question is based on this scale. So the first statement says that the intensity of the earthquake is measured by the Mercalli scale. So let us first discuss what are the major difference between the Mercalli and the Richter scale. Then we will come back to this question and answer this particular question. So you see here the Mercalli scale, it usually measures the effect caused by an earthquake, that is the intensity. So what is that? Let's say in case of a Mercalli scale, it calculates how much damage this particular earthquake has caused to the earth. Let's say the earthquake is happening in a particular location, and in that particular location, how much people died, or how much buildings collapsed, how much man-made structures they got affected by this particular earthquake. That is what calculated in the Mercalli scale. We say this as the intensity of the earthquake is being calculated by the Mercalli scale. But in case of Richter scale, they are not going to calculate the intensity of this earthquake. What they are going to calculate? They are going to calculate the magnitude of this particular earthquake. What is this magnitude? Let us say Let us say this is the surface of the earth and this is the interior of the earth and this is a point in the interior of the earth. And this is the point where this earthquake has started. The rupture of, because of the rupture of the rock, there is a sudden release of energy, and in this particular point, the earthquake has been started, and this particular point is called a what? Focus. Okay. So now, if you see here, this Richter scale, they are going to calculate how much energy this particular earthquake has released. How much energy has been released by this particular earthquake. So they are going to calculate this in the Richter scale. Richter scale, the energy released by an earthquake, that is the magnitude of an earthquake. In Mercalli scale, they are going to calculate the intensity of the earthquake. So this is intensity and this is magnitude. And the second point is quantified from the observation of the effects on the earth's surface. That's what. How can you calculate this? By observing the damages happened on the earth's surface. How much people died or how much magma structures they got damaged. So because by doing this, they will be calculating the impact, the intensity. But in case of Richter scale, they are going to calculate the amplitude of the wave. Okay. Then if you see here in this particular Mercalli scale, it is a linear scale. It would be varying from 1 to 12, but it is a linear scale. When you are comparing 1 to 2, it will be increasing in a linear fashion. But in case of this Richter scale, we have a logarithmic scale. When there is an increase, let's say there was an earthquake which was recorded 2, and there is another earthquake which has recorded 3. So there will be an increase in 10 times of the energy which has been released. So whenever you are comparing 2 and 3, there will be increase in 10 times of the energy. And when you are comparing 3 and 4, again there will be a 10 times more energy has been released. But when you are comparing 2 with 4, there will be 100 times more energy which has been released. This is the Richter scale. And the consistency, if you see the Mercalli scale, it varies depending on the distance from the epicenter. Let's say, we know that, let's say this is the earthquake, this is focus, and when once it's reaching the surface, the shortest distance between the focus and the surface of the earth, and this point is called as the epicenter. So let's say this particular earthquake epicenter is this point, and we'll take some other point which is somewhat far from the epicenter. Now if you compare the impact in the epicenter, the location of the epicenter, and the impact in this particular point, the location which is on the epicenter of this particular earthquake, the impact or the intensity is going to be very high compared to the other point which is somewhat away from the epicenter. So based on the location of the particular area, so if you are calculating with the Mercalli scale of this earthquake, this particular location will be having a higher value and this particular location will be having somewhat lower value of this earthquake. So the location is actually changing the impact of the earthquake. But in case of the Richter scale, if you are calculating from the epicenter or if you are calculating somewhat away from the epicenter, it doesn't matter. Why? Because they are going to calculate how much energy has been released from the focus. They are not going to calculate what happened to the surface of the earth. They are going to calculate how much energy has been released from the particular earthquake. So wherever the location may be, it may be the epicenter or it may be far away from the epicenter, the value which is calculated by the Richter scale is going to be the same. Wherever you go, it's going to be the same because it's going to be calculated from the focus and not from the surface of the earth. So these are some of the major difference of the Richter scale and the Mercalli scale. So the first statement is intensity of earthquake is measured by Mercalli scale. Is that true? Yes, just now we saw the Mercalli scale specifically calculates the intensity of the earthquake. So this particular statement is correct. Then the magnitude of earthquake is the measure of energy released. And we saw in the Richter scale, it is going to calculate the magnitude of this particular earthquake. So this particular magnitude is nothing but it is going to measure the energy released from the focus. So this particular statement is also correct. Then third statement, earthquake magnitudes are based on direct measurements of amplitude of seismic waves. Is that true? Yes, we read in the Richter scale that the earthquake's magnitude is actually based on the amplitude of the seismic wave. This statement is also correct. Then fourth statement, in the Richter scale, each whole number demonstrates a 100-fold increase in the amount of energy released. We also see this, let us say, when there is a earthquake of 2 and then there is a earthquake of 3. When you compare these two, this would be 10 times higher, right? And when you are comparing this 3 to 4, again, there will be increase in 10 times of the energy released. But when you are comparing 2 with 4, you will be having 100 times higher energy. But in the question, what they are asking, when one whole number to another whole number, there is an increase in 100-fold. Is that true? No, there is an increase in 10-fold. There is no 100-fold. Okay. So this particular statement is wrong. So what would be the correct answer? Option A, 1, 2 and 3 is the correct answer. Then let us go to the next question. Consider the following statements made about the sedimentary rocks. Statement 1, sedimentary rocks are found at the earth's surface by the hydrological system. Statement 2, the formation of sedimentary rocks involves weathering of pre-existing rocks. Statement 3, sedimentary rocks contains fossils. Statement 4, sedimentary rocks typically occur in layers. So if you see here, they are talking about the sedimentary rocks. And if you see, most of the cases, we have majorly 3 types of rocks which we used to study. One is igneous rock, the another one is sedimentary rock, and the another one is metamorphic rock. So what are these 3 types of rocks? Let us have a look at it and then we'll try to solve this question. So if you see here, yes, this is a basic rock cycle, the cycle of the rock, how the cycle is going to form different types of rocks, the igneous rock, the sedimentary rock and the metamorphic rock. So let us have a look at it. So if you see here, this is a volcano and this particular magma is coming out and this lava after a point of time is going to solidify. And as I already told you, the magma which is inside the earth, it is also going to solidify when it is like filling some of the cracks or the gaps in the crust. And these are some of the intrusive features, right? These are some of the extrusive features where the magma gets solidified after the volcanic eruption and it gets solidified on the surface of the earth. So maybe it is on the surface, or you can consider the intrusive features also, which is inside the earth. Both these solidified features, they after some time going to form some rock. These rocks are called as igneous rock. So igneous rocks are nothing but the solidified magma, be it inside the earth or outside the earth, no issues. But these solidified magma are called as igneous rocks. Then what happens? This igneous rock, it will go through weathering. What is weathering? When some of the agents like water, wind, these weathering agents are coming and eroding this particular rock. Then this rock will slowly, for thousands of years, what will happen? It will slowly start to erode and it will become fine particles. If you see here, yes, it will become fine particles and these particles are called as sediments. And then after some more time, some of the agents, they carry away these sediments like wind, water, glacier. They are going to carry the sediment and they are going to place it in somewhere else, some other location. And what happens is these sediments, they are coming and forming a layer. And after some years, another layer, then another layer. So slowly, each and every layer is formed. and after a point of time each layer are also going to stick together. They will become somewhat compact, and after some point of time they will be forming a rock, and this rock is called as a sedimentary rock. The name itself says sedimentary. What it means? These sedimentary rocks are formed by the sediments. The sediments are going to fill layer by layer, layer by layer, layer by layer, year after year, and they are going to form this particular rock. And this rock is called as sedimentary rock. Then what happens is this sedimentary rock, it goes through high pressure or high temperature. So when going through high temperature and high pressure, this sedimentary rock for like years and years and years after, it will transform into another type of rock, that is a metamorphic rock. Okay, so this metamorphic rock will again, after some time, it can melt and form the base of the magma, and then it can again come out of the magma, volcanic eruption, then again form the igneous rock. So this cycle will be continuing again and again. This is a basic cycle, very basic form of the rock cycle, but there is a complicated one also. We'll be seeing it in detail. But just for the understanding, this is how these major rocks, igneous, sedimentary and metamorphic rocks are formed. And these are some of the examples of the igneous rock. Sometimes you might be given these names: basalt, granite, gabbro. They'll be giving the names, the examples, and they will be telling you whether this particular rocks are igneous rocks or this particular rocks are sedimentary rocks. They'll be asking this type of questions also. So it's better if you remember some of the examples, it would be helpful for you. And this is the sedimentary rock. These are some of the examples of the sedimentary rocks. So if you see here, depending upon the mode of formation, sedimentary rocks are classified into three major groups. So we saw sedimentary group, sedimentary rock, how they are going to form the sediments. They are going to come and place and layers and layers. They are going to form a rock, and this rock is called as a sedimentary rock. But there are three different categories. We can categorize the sedimentary rock based on the type of formation. And what are these three types? One is mechanically formed, the another one is organically formed, the another one is chemically formed. And these are the examples of the mode of formation. And let us understand what are these types of sedimentary rocks. First is mechanically formed. The example which I gave you, the sediments, they are going to come, they are going to form the layers, and layer by layer, they are going to form the rock. So this basic way of forming the sedimentary rock is a mechanically forming sedimentary rock. We can call them as mechanical sedimentary rocks. And the second type of organically formed sedimentary rocks. What are these organically formed sedimentary rocks? Just like the sediments, along with the sediments, sometimes the dead plants, dead animals, dead corals, just like this, the organic things are going to, they are also going to form some of the sediments, right, after the erosion, after the weathering. So these sediments are going to, along with the sediment of other elements, these are going to mix up, and then they are going to form the layers, and then they'll form a rock, and this rock is called as organically formed sedimentary rocks. So technically, this organically formed sedimentary rocks will be containing fossils of like thousands of years before. There are some animals, or there are some plants. They are going to contain those fossils inside the rock. Okay, so this is organically formed rocks. Then the chemically formed rocks. What are these chemically formed rocks? So when you see, when the same sediments are there, these sediments sometimes are made up of the minerals, and some minerals are actually, they can react in a chemical way. We can say they can have the chemical reaction whenever they are going through some high pressure, or whenever they are going through some high temperature, or whenever they are going through very low temperature, very cold temperature. So based on different these nature things going to happen, they are going to react in a particular way, and some sort of chemical reaction is going to happen. And due to this chemical reaction, these sedimentary rocks are formed, and these sedimentary rocks are called as the chemically formed sedimentary rocks. So these are the three types of the sedimentary rocks. Then we have metamorphic rocks, and I already told you, when the sedimentary rocks, they are going through some of the high pressure or high temperature, like year after year after year, then slowly they will be forming another type of metamorphic rock. They are called as metamorphic rock. There will be recrystallization. They will be having a restructure of their particular rock. So this is metamorphic rock. Now let us go back to this question. Before that, yes, I told you the first rock cycle which we saw, it was a basic type of a rock cycle. This is somewhat a complicated type. Just to understand, let us try to understand this. As we saw, yes, this is magma. Then after cooling, what will happen? They will be formed as a igneous rock. So after cooling, they will be forming the igneous rock. Then after some time, when the weathering happens, when the erosion happens, these rocks are made into fine particles, fine grains, and these grains are called as sediments. Then what happens? This sediments, after some time, they are going to go and settle in some area, and they're going to form layers and layers of these sediments, and then finally these layers are also going to compact with each other, they're going to stick with each other. Then with the time passes, they will be forming a rock. That rock is called a sedimentary rock. Then this sedimentary rock, when it goes through high pressure and high temperature year after year, they're going to form the metamorphic rock. Then what happens when this metamorphic rock is melted with very high temperature? When this metamorphic rock falls in a magma, then it got melted, and it will form as a magma. It will convert as a magma. Then again this particular cycle will be going on. This is what we saw in the normal rock cycle, the basic rock cycle which we saw in the previous one of the previous slides. Now there are other ways also. This is not the only way of like forming the rocks. There are other ways also. There are different ways. If you see here, if you see this magma, when it's getting cool, it will be forming a igneous rock. But when it is melting again with a high temperature, it can again get converted into a magma. So this is one way. Then let's say when we are having this particular weathering, and then the sedimentary rocks are formed because of the sediments. This sedimentary rocks, without going through high pressure and high temperature, when it's going through some sort of weathering, it can again become sediment, and this sediment again can become a sedimentary rock. This is also a way. Then what are the other ways? Let us say this sedimentary rock going through high pressure and high temperature, they are forming a metamorphic rock, but instead of melting and becoming a magma, it can also go through weathering and become sediments. Then these sediments are going to be forming sedimentary rock, right? Then there is another way also. When the igneous rock, instead of going through liquefaction or weathering and becoming sedimentary rock, it directly undergoes high pressure and high temperature, and the igneous rock can directly be converted into a metamorphic rock. So these are some of the different ways how the cycle goes on. Okay, so these are some of the different ways. There is no single way of forming these rocks. So this particular question talks only about the sedimentary rocks. We read about the three rocks, the igneous, sedimentary, and the metamorphic rocks. This particular question talks about the sedimentary rocks. Statement 1 says that sedimentary rocks are formed at the Earth's surface by the hydrological system. Is that true? If you see, the sedimentary rocks are usually formed on the surface of the Earth. We saw the igneous rocks. They can be formed inside the Earth also, or outside the Earth also, on the surface of the Earth also. But these sedimentary rocks are going to be formed in the surface of the Earth, because these traveling agents like wind or water, glacier, river streams, waves, these are going to carry the sediments from one place to another, and slowly some sort of layers of these sediments are going to be formed, and then the sedimentary rocks are talking about that sedimentary rocks are formed in the Earth's surface. Yes, that is true. Then they are saying that it is formed by a hydrological system. Is that true? If there are waves, like there are when the waves, sea waves, or we can say the river streams, we can say these hydrological systems are responsible for forming some of the sedimentary rocks. So this statement would be a correct statement. Then statement 2, the formation of sedimentary rocks involves the weathering of pre-existing rock. This is one of the important points we read in the sedimentary rocks. What are they saying? For forming any sedimentary rock, there is a need of a pre-existing rock. When there is already an existing rock, this existing rock, after weathering, it will become fine particles, fine small elements, sediments, and these sediments are going to be forming layers, and then this layer is going to form a sedimentary rock. So there is a need of the sedimentary rocks. They need pre-existing rock and the weathering of the pre-existing rocks. These are needed. Either it may be an igneous rock, or it may be a metamorphic rock, or it may be a sedimentary rock also. But it need a pre-existing rock, and it should go through the weathering process, and then only the sediments are formed. Okay. So then, third statement is sedimentary rocks contain fossils. Is that true? Just now we were talking about the sedimentary rocks, and one of the type of sedimentary rock is organically formed sedimentary rock. So what is this organically formed sedimentary rock? Along with the sediments of minerals, another organic things like plants, animals, corals, or any marine animals, organisms. These, after they die, these particles, these small sediments of these organic things are going to mix up with this particular mineral, and they are going to form a rock. And this is called as organically formed sedimentary rock. And we are seeing this, the sedimentary rocks can also have fossils, yes, because they are going to be containing some organic matter after the death of plant, animal, or any other species. So it is going to contain the fossils of any particular species. Then statement 4, sedimentary rocks typically occur in layers. Is that true? We already saw, yes. Whenever we need a sedimentary rock, how it is going to be formed? The sediments are going to be carried away, and it is going to form a layer and layer after layer. The what do you say, layers are going to be formed, then only the sedimentary rocks can be formed, right? So these sedimentary rocks are always formed by the layers. So typically they occur in the layers. So this statement is also correct. So what is the correct answer? The correct answer is B, 1, 2, 3, 4. So we have the next question. Volcanic eruptions do not occur in Baltic Sea, Black Sea, Caribbean Sea, and Caspian Sea. So if you see here, the volcanic eruptions, they don't occur everywhere, right? There are some causes for why a volcanic eruption is happening in any particular location. It can't happen everywhere. Okay. The major cause for any volcanic eruption, there is the presence of volcanoes, is that particular location is going to be there in a, what do you say, the boundary of any plate. We can say the plate boundary. So we have different sort of plate boundaries. So these plate boundaries are one of the major cause of the volcanoes, the presence of volcanoes and the volcanic eruptions. So if you see the Baltic Sea, this would be the correct answer. It does not have any volcanic origin. Why? Because there is no plate boundary near the Baltic Sea. Plus the rocks which are found under the Baltic Sea, they are of glacier origin. They are not having any volcanic origin. So the correct answer would be option A. So the next question, a ship sailing from the eastern extremity of Aleutian Island to the Dutch harbor crosses the 180 meridian at the 23:30 hours, that is 11:30 p.m. on January 1st, 1999. What time and date will be recorded by the captain of the ship in his diary after 1 hour journey? So these are the keywords. From the point of crossing the meridian. Option A, January 1, 0030 hours, January 2 0030 hours, January 3 0030 hours, January 4 0030 hours. So what they are saying here? They are simply saying that a ship, it is sailing, let us say in the Pacific Ocean, okay, and it is sailing from the eastern extremity of the Aleutian Islands to the Dutch harbor, and it is crossing the 180 meridian. This is one of the key points you have to notice. It is crossing the 180 meridian. That is, what is 180 meridian? 180 meridian is nothing but the international date line. International deadline is also called as the 180 meridian. And what is the time when it crosses the international deadline? That is 11:30 p.m. So around 11:30 p.m. on January 1st, 1999, this particular ship is crossing the international deadline, that is the 180-degree meridian. So if you see the location of the Aleutian Island, it would be around this particular area in the Pacific Ocean, and the eastern extremity would be here, and the Dutch harbor would be somewhere here. So which means this particular ship is traveling from the western direction to the eastern direction. Okay, this thing you have to notice. Why? Because whenever someone is crossing the 180 meridian, that is the international deadline, from the west towards to the east, what will happen? He will be losing a day. But when you are crossing from the east to west, the international deadline, you will be gaining a day. So as soon as this ship, once it crosses the international deadline, in this case, it is going to lose a day. So let us say this ship, once it crosses the international deadline, it lost a day, which means the date would be what? It's not January anymore, it's December 31st of 1998. One day, previous day. Okay, previous day. But the time would be the same time. The time would be 11:30 p.m. but on December 31st, 1998. But what are they saying is, the ship travels for 1 hour after crossing the 180 meridian. So now it is going to travel for 1 more hour. So already the time was 11:30, but after 1 hour it would be what? It would be 12:30 a.m. Okay, it would be 12:30 a.m. after 1 hour of the travel. But once you cross the 12 a.m., it would be the next day. So once it is 12:30 a.m., we can say that the date would be the next date of December 31st, 1998. So the next day of December 31st, 1998 is nothing but January 1st, 1999. So what would be the exact time after 1 hour of the travel? It would be Jan 1st. Yeah, no doubt about it. 1999. No doubt. The time would be 12:30 a.m. Okay. So what would be the correct answer? The correct answer would be Jan 1st, 0030 hours. So this is the correct answer. So the next question, which one of the following scholars suggests the Earth's origin from gases and the dust particles? Option A, James Jeans. Option D, H. Alpin. Option C, Hoyling. Option D, Kimmel. So this is one of the basic questions. We usually read about the origin of Earth and origin of universe, the first chapter in the geography. So the correct answer would be O. Kim. He proposed this particular, is related to this particular theory. He said that the Earth's origin is from the gases and the dust particles. Then the next question is, which one of the following types of coal contains a higher percentage of carbon than the rest? Option A, bituminous coal. Option B, lignite. Option C, peat. And option D, anthracite. So before answering this question, let us have a look at what are these types of coal and how they are actually being formed and what is the percentage of carbon content in this coal. So first see this picture here. So first they are talking about peat. So peat is the first stage of becoming a coal. So this peat It is a partially decayed matter of any plant and it is a low heat content. Okay, then after going through high pressure and high heat for some years, this heat is going to be converted into lignite, and this lignite is also known as brown coal. And this brown coal is low heat content and it has low sulfur content and it is limited supplies in the most areas. Okay, then after going through some more heat and pressure, this lignite is converted into bituminous, and bituminous is also called as soft coal. So this bituminous is extensively used as a fuel because it has high heat content. But what is the issue with bituminous? It has high sulfur content. You have to remember this also. The bituminous contains high sulfur content. So that is the issue. Then after going through more heat and more high pressure, this bituminous is going to convert into a anthracite. Anthracite is also known as hard coal, and this is highly desirable fuel because it is high heat content and a low sulfur content. Bituminous is having high sulfur content, but anthracite is having a low sulfur content. So that's why this is highly, desirable, and this is the process of how the coal is being formed in every stage. And the highest stage would be anthracite, that is the hard coal, and mostly they prefer anthracite. Why? Because it has more carbon content. If you see here, you can understand lignite, it is having 65 to 70% of the carbon. This is some bituminous coal, 70 to 76% of carbon. Bituminous coal is having 76 to 86% of the coal, and anthracite is having the highest amount of coal percentage, that is 86 to 92% of the coal carbon. So when we come back to this question, they are asking which of these following is having higher carbon content. What is that? It is the anthracite because it consists of higher percentage of the carbon. So option D is the correct answer. Then if you see next question, I think this is question number 8. What is this? At which one of the following positions shown in the diagram will height of the ocean tide be maximum? M1, M2, M3, M4. So if you see here, this is the position of the sun, and we know that the earth revolves around the sun, and this is the position of the earth. So this is the earth's position, and this is the orbit of the moon. The moon revolves around the earth, and they have given 4 positions: M1, M2, M3 and M4. So what they are asking is, what is the position of the moon which actually decides the highest tide of the ocean tide, highest ocean tide. So you should be saying whether it's M1, M2 or M3, M4. So if you see here, what we can see is the M1 position and the M3 position are in perpendicular direction with the sun. It is perpendicular to the sun, the M1 and the M3. So what it means? It means that when the sun and the moon are in different direction and they are in especially perpendicular direction, the sun is going to have a gravitational pull and the moon is going to have a gravitational pull on the other side. So we'll be having a low tide. So both this M1 will be having a low tide and in M3 we'll be having a low tide. But when in case of M2 or M4, it is the moon, earth and the sun are going to be in the straight line. So we'll be having high tide. Why? How? Let us say the sun is there. Obviously the sun is going to have a gravitational pull on earth. So there is a tide which is formed on this side. But also we know that when there is a tide is formed, the opposite side of the earth is also going to have the counter tide. So there will be a tide on this side also. Now let us consider the M4 position of the moon. So again, let's M2 position of the moon. Let us consider M2 position of the moon. So now what happens is the pull. It is on one side sun's pull, one side the other side the moon's pull is there. So So what will happen? This moon's pull is going to create some of the ocean tide. So this is going to be a high tide. And when you see the M4 position again, when the moon is in this position, what is going to happen? This time it is going to have high tide, no doubt about it. But when there is a pull of sun and the moon together, they are in the same direction and they are pulling the earth by their gravitation. So now this time it is going to be a high tide, but this high tide is going to be the highest compared to this high tide. Okay, so what would be the correct answer? The correct answer is D. When the moon is in this position, let's say the earth, the moon and the sun, they are in the straight line and the moon is in between the earth and sun. In that case, we will be having the highest ocean tide. So the correct answer is M4. And if you see here, yes, this is the 4th position of the moon. In the first case, they are saying that the moon, earth and the sun, they are going to be in the straight line. Whenever the moon is in the opposite side of the sun, the moon is in this side and sun is in the opposite side. So the sun's gravitational pull is going to create a tide and there is going to be a counter tide on the opposite direction. Now the moon's gravitational pull is going to create a tide and there is going to be a opposite tide, counter tide, yes. So this particular tide is the high tide and we can also call it a spring tide. But when the moon's position is in this new moon position and the moon is between earth and sun, what is going to happen? In this case, both the sun and the moon are going to create a much more high tide because both the sun and the moon is in one direction and they are having a higher gravitational pull. And again, there is going to be a counter tide. So this high tide, this is also a high tide, but this high tide is higher compared to the first case, in the full moon case. Okay, so these two tides are called as spring tides. These both tides are high tides. Then we have neap tides. What are they? When the moon is in the first quarter moon and the third quarter moon position. Now the moon's position is perpendicular to the sun's position. In both the cases, if you see this, it is perpendicular to the sun's position. What is happening? The sun is having a gravitational pull here and the moon is having a gravitational pull downwards. Now what is happening? Due to both of the gravitational pull on this side and this side, it is somewhat compressing, right? So there is no cause of high tide and it will be a low tide here. And the same with the case of this position also. So both these are low tide and this is called as neap tides. So the next question, when there is a noon at a GMT meridian, people on another planet of the earth are taking their 6 o'clock morning tea. The longitude of the places, option A, B, C, D. So technically what they are saying, that it is noon at a GMT meridian. What is GMT meridian? Just like we saw in one of the previous questions, the international deadline is called as the 180 meridian. Just like the GMT meridian is the 0 degree meridian. So GMT is nothing but the 0 degree meridian. Let us say this is the 180 meridian and 180 meridian is what? International deadline. So now what they are asking is when it is when it is noon at the GMT. So they are saying at the GMT it is 12 p.m. Okay. Another part of us, people are having their 6 o'clock morning tea. So what they are saying is when it is 12 p.m. at the 0 meridian in another location of the earth, it is 6 a.m. Morning tea means 6 a.m. So when would be the 6 a.m.? Let us see here. When from the GMT, when you are moving towards east, you will be gaining time or you will be losing time. Let us take our case, okay? We have Indian Standard Time, IST. So, is IST ahead of GMT or it's behind GMT? Just think. They are actually ahead of GMT. If it is, what do you say, there is some time in GMT, we are ahead of 5 hours 30 minutes exactly from the GMT. We are ahead of GMT, okay? So whenever you are moving in the east direction, you are going to gain the time, and whenever you are going in the west direction, you are going to lose the time. Okay. So now it is 12 p.m. in the GMT, but we want 6 a.m. in the morning. So it would be this side or this side. It would be on the west side. When you go towards the west side, you will be having the 6 a.m. the time 6 a.m. which means you are losing time. It is 12 p.m. here, right? So we are moving west side. This is clear. First case, the west is clear, so we can eliminate this option. The two options are there. Now we have to find out how much longitude we are moving. So how will we calculate the longitude? So if you see here, there is a basic fact which we use to study when we are doing the static portion. So what is that? When you are moving 15 degree in a latitude, okay, you can move in either direction, no issues, but there is a change of 1 hour. Okay, if you are moving west side, obviously there is going to be 1 hour minus. When you are moving towards the east direction, there will be a gain of 1 hour, right? But whenever you are moving 15 degree longitude, there will be a difference of 1 hour. Now we know that this is 12 p.m. in GMT, and we are going to some location. It is 6 a.m. in the morning. So what is the difference between these two? It is 6 hours. There is a 6 hours difference, right? Now we want to find out the longitude. For 1 hour, I told you it's 15 degree longitude. So for 6 hours, how much degree longitude will be there? So 6 into 15. It would be 90 degrees. So what would be the correct answer? Option D, 90 degree west. Towards the west they are moving. So answer is option D, 90 degree west is the correct answer. So the next question, if the Earth's direction of rotation is reversed, what would be the IST when it is noon at the international deadline? Option A, B, C, D. So what they are saying is, when the Earth's direction is reversed, we all know that Earth's direction, the rotation of the rotation is in the direction of from the west towards the east. So what they are saying is, in case the direction is reversed in a hypothetical sense. So they have given some condition, and they are asking in that condition what would be the time in the IST, that is the Indian Standard Time. So what are the given information? Let us first see that in international deadline, let's say this line is international deadline, that is the 180 degree meridian. So this particular international deadline is having a what? 12 noon, 12 p.m. The time is 12 p.m. And there is another line, we know that is the zero meridian. We call it as GMT, Greenwich Mean Time. And in between, somewhere in between, we have the Indian Standard Time, IST. Okay, this thing we know, basic. Now, when it is 12 p.m. in the international deadline, what would be the time in the GMT? Simple, it is going to be 12 a.m. Okay, because the GMT and the international deadline is going to have like half of the Earth covered from here to here. It's 0 degree and that is 180 degree. Exactly on the opposite direction this line is having. This line is there. So it is going to be 12 a.m. in the GMT and 12 p.m. in the international deadline. So in normal condition, first let us see what is going to happen in the normal condition, and then we'll go to the hypothetical condition given in the question. So in the normal condition, when it is 12 a.m. in the given GMT, what is going to be the time in Indian Standard Time? Indian time would be, we know that we are 5 hours 30 minutes ahead of the GMT. So we will be technically adding 5 hours 30 minutes to this time. So our time would be 5:30 a.m. Okay. So this would be the time in the Indian Standard Time. So this is a normal case. In the normal case, what's happening? Sun is going to be rising in the east, this side, from this side, and it will be moving towards the west. So that's why we have 12 p.m. here, 5:30 a.m. here, and 12 a.m. here. The people who are near the international deadline, from the east towards the west, they are going to face the sunrise first. And the people near the GMT are going to face the sunrise much later. That's why the time are ahead here compared to the GMT. This is the normal case. Now let us go back to the hypothetical case given in the question. In the hypothetical case, what they are saying is the reversal of the reversal of the rotation of Earth. So now the Earth is rotating from the west to east, not the east to west, not the west to east. So the sun will be rising from this side, from the west. So whatever condition we see here, it would be reversed, right? So they are saying international deadline, the time is 12 p.m. So let us say in the hypothetical case, the time in the international deadline would be 12 p.m. What would be the time in GMT? It is going to be 12 a.m. No issues. Why? Because this is 0 degree, that is 180 degrees. So which means it is equally dividing the Earth, like this side half and that side half. So total is 360 degrees. So the 0 degree, if it is 12 a.m., the 180 degrees is going to be 12 p.m. Simple. So this is 12 a.m., this is 12 p.m. No confusion. But what would be the time in the Indian Standard Time? So in the normal case, we are ahead of 5 or 30 minutes. But in the hypothetical case, because the sun is rising from the west and it's going towards the east, now what's going to happen? These people who are in the western side are going to face the sunrise first, and these people who are IST or international deadline near that longitude, they are going to face the sunrise much later compared to these people in the western side. So we are going to be behind the time compared to the GMT. So what we are going to do? We are going to minus 5 or 30 minutes from this particular time. So when you are minusing, when you are subtracting 5 or 30 minutes from 12 a.m., what would be the time? It would be the previous day's time, and the correct time would be 6:30. The previous day, so it is PM, the evening of the previous day. So simply, what is the time in Indian Standard Time? The time would be 6:30 p.m. So the correct answer would be C, 18:30 hours. Okay. Then, next question. The standard time of the following countries is ahead or behind Greenwich Mean Time, depending on whether they are east or west. This thing we know. Let's say this is the 0 degree. We know that this is the GMT, Greenwich Mean Time. So when you are going towards the east, the time, the people who are living in the eastern side of the GMT, they are going to have the time which is ahead of the GMT. When you are going towards the west, they are going to have the time which is behind the GMT. So they have given some locations like Cuba, Greece, Iraq, Costa Rica, and Japan. So they are asking that arrange this following in sequential order, gives that the correct arrangement of the countries according to their standard time from ahead to behind. So what is the order? What is the order going to be? Ahead, from the ahead time to the behind time. So we simply know when you are moving towards the east, you are ahead, and when you are moving towards the west, you are behind. So simply they are asking, arrange these following countries from east to west. Simple. Okay. So even though you don't know the exact location of many of these given options, let us try to answer this particular question. You must know at least the Japan. It is one of the first countries which is going to have the sunrise. Okay, it is going to see the sunrise in a particular day. So let's say this is the international deadline. This line, this particular line is international deadline. It is the 180 degree meridian. So this Japan is going to be somewhere near the international deadline, and it is going to face the first sunrise, one of the first sunrise. I'm not telling Japan is the first country to have the sunrise. No, I'm telling it is one of the first countries to experience the sunrise, right? So when Japan is here, you know that it is going to be the easternmost compared with other. So we know that Cuba, Greece, Iraq, Costa Rica, these are not in the eastern side. These are somewhat western towards the Japan. We know this basic fact. So Japan is going to be the first one in the given option. So if you see, only A is the option which contains Japan as the first order. Okay. So the answer would be option A, but still let us see where are this going to be located. And if you see, let us go back, let us go to this particular map here, world map here. We know this is the Greenwich Mean Time, and let us imagine that we have the 180-degree meridian here, that is the international deadline here. So if you see Japan, yes, it is going to be the first country, one of the first country, but in this given option, it is going to be the first country. Okay, so Japan is first country. Then they have given Iraq. Iraq is somewhere here. That is going to be the second country. Then they have given Greece. Greece is going to be, it is a European country, so it is going to be here somewhere here. Then they have given Cuba. So it's going to be the fourth country. Then we have Costa Rica. It's somewhere here. So if you see, the order would be Japan, Iraq, Greece, Cuba, and Costa Rica. So this would be the correct order. So Japan first, then we have Iraq, then we have Greece, then we have Cuba, then we have Costa Rica. So the answer would be 5, 3, 2, 1. Option A is the correct answer. But sometimes there is no need you know all the options. In this case, we just know about the Japan. Even though you don't know the location of other given things, at least you know the location of Iraq. Okay, you know Greece is one of the European countries. You know some of these. Even though you don't know everything, you might be able to solve the question. Okay, so our objective is solving the questions, not like going through each and every fact. Okay, but with this, I think you might be able to understand how the time zones are, how we calculate the questions based on the time zones also. With this, we are completing the physical geography. Okay, we have completed 3 videos. So this is the part 3 of this particular topic, and we have completed the physical geography. We will be starting with the next topic in the next video. So thank you, students.